Welcome to all in the next lecture on propositional logic. So here we will discuss about the how can we convert our atomic proposition into the uh, atomic proposition into the compound proposition by using the connectives. In earlier lecture, we studied about the connectives that are negation, conjunction, disjunction, and the conditional statements. So now here, first we talk about the compound statement. So here we have the two propositions P, that is the you learn the simple things well, and Q is the difficult things become easy. If we have these two propositions, so we have to write these propositions in the form of P and Q, means we have to represent these propositions in the form of P and Q. So how can we represent it? First we have suppose you do not learn the simple things well. So here we see that this is the P and do not here, it means that that is the negation of P. So what will be the representation of this statement? That is negation of P. Next, if you learn the simple things well, then the difficult things become easy. So here which connective use here? If then. So conditional connective is used here, and it is if you learn the simple things well, means if P, then the difficult things become easy, Q. So this is the representation is P implies Q, right? Next, if you do not learn the simple things well, then the difficult things will not become easy. So we do not learn the simple things, means we use here the negation of P. And if then here, it means implication is used here, and the difficult things will not become easy. So negation of Q, right? So it is your negation of P implies negation of Q. Next, the difficult things become easy, but you didn't learn the simple things well. So here we have difficult things become easy. So it is your Q, and you did not learn the simple things well, means negation of P. So it is your Q and negation of P. Next is you learned the simple things well, but the difficult things did not become easy. It means that this is your P and negation of Q. Clear? P and negation of Q. So this here we represent our statements, English statements into the representation of P and Q. So this is called the informal representation of the proposition, and this way is called the formal representation of the proposition. So here we change our informal proposition into the formal proposition. Clear? So now here next is we take that precedence of logical operators. So what is the precedence? If we can use parentheses to specify the which logical operators in a compound propositions are to be applied, right? We use the parentheses, but to reduce the number of parentheses, the precedence order is defined for logical operators. So here we have the precedency of the logical operators, right? We studied about the operators, we connectives, negation, conjunction, disjunction, implication, and the biconditional, right? So what is the precedency of this? First, if we have these operators, so first precedence we have to first take the solve the negation. So this is the first negation, we use the negation first, then we use the conjunction and this after that the disjunction, and after that use the conditional, and after that we use the biconditional. So this is your the precedence of the logical operators. Like an example, if we suppose we need to calculate negation of P and Q, so how to solve this? First what you calculate? First you calculate the negation P, means it is like that. First you would calculate negation P, then you can take the conjunction with Q, right? If we have suppose P and Q or R, so how can you solve this? First you need to calculate conjunction, means P and Q. After that you calculate over R, disjunction R. Clear? If you have suppose P or Q and R, so how to solve this? First you need to calculate conjunction, right? So first we calculate Q conjunction R, then disjunction with P. Clear? How can we use these operators? So now here we have some simple exercises here. If suppose we have P proposition is today is Wednesday and Q proposition is it is raining and R is it is cold. So here we write the simple sentences, the meaning of the following, means we have these propositions, compound propositions these are. What is the compound proposition? Where we combine the two propositions like P, Q, R, the two or more propositions by using the connectives, right? So that is the compound proposition. So here we have the symbolic form of the proposition and need to write the simple sentence, right? Means in English statement, how can we write this? So if we have the negation of P, so, and what is PR? P in English sentence is today is Wednesday. So, what is the negation of P? It is called today is not Wednesday. Simple. Just we have to take the negation here, right? Next, if you have suppose Q and this is your conjunction and negation R. So, this is Q is it is raining and what is that negation of R? It is not cold. So when you combine this is it is raining but not cold. Right? What is the meaning of this? Q and negation of R. Next you have suppose P implies R. So what is P implies R? Today is Wednesday, P and R is it is cold. So implies means we use here the connective if then. So if P then R. So it is if today is Wednesday then it is cold. Next, negation of P or Q or R. So here, what we use here? Actually, here we have the or. So we can't write that negation today is not Wednesday or it is raining or cold. No, if you have the like that or operations are two, so you have to write that either today is not Wednesday or it is raining or cold. So you have to use the either here, right? Because after you not write that today is not Wednesday or it is raining or cold. No, this is the uh, ambiguous English statement, right? So you have to write that like that either today is not Wednesday or it is raining or cold. Next, you have the negation of negation R. So, just simply negation R what? The negation of this, the negative sentence of this, that is, it is not cold. But here we have the again negation of this. So, how can you do this? So, what we can write this? We can write this in sentence in our proposition. It is not true because this is for the negation. It is not true that now negation of R, it is not cold. So if you have the double negation, so you have to write like that. It is not true that it is not cold. Clear? So here this is are the formal proposition. These are the informal proposition way. So here we convert our formal proposition into the informal proposition. Clear? So like that you can solve your questions. Means we can ask that you convert your proposition English statement proposition into the representation of P and Q, and P and Q represent in the English form of the proposition. Clear? How can we do this? Next, we have the truth table, means how can we represent our compound propositions by the truth table. So We can use connectives to build up complicated compound propositions involving any number of propositional variables. Means we have many propositional variables. We can use p, q, r, like that. Truth tables to determine the truth value of these compound propositions. So here we construct our the truth table of the compound proposition. Suppose we have this is all truth table. You earlier studied that what is the truth table of negation, what is the truth table of conjunction, and what is the truth table of disjunction, conditional, right? So now here we have the combined compound proposition is there. So here we use the many connectives. Here we use the disjunction, negation, conditional, conjunction, all we use here. So now we make the compound proposition. So how can we represent it by the truth table? So here we make our the truth table. So for to make the truth table, what we have p and q, right? And we know that if we have the two variables p and q, so how many number of rows here? 4 to the power 2. 4 rows are here. So our truth values are true, 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 false, false, true, and false, false, right? So to calculate this proposition, first we can need to calculate negation of q. So if we our q is this, so what will be the negation of q? If we have true, then negation of q is false. If we have false, then negation q is true. If we have true, then negation of q is false. If we have false, then negation of is true, right? So like that, first column is for negation of q. So here our parenthesis is given here. So first we calculate this p or negation of q. P is here we have and negation of q we have. So now we have to use the or with p or negation of q. And what is in our or means in our disjunction? What is that? If in our disjunction is that if our all both are false, then it is false, otherwise it is true. So our statements are if true false, then it become true, true true, then it become true, false false, then it become false, and false true, so it become true. So in our disjunction we earlier studied that the truth values are only false if both our statements values is false, otherwise all are true. Clear? Now next we need to calculate P in conjunction D Q. P conjunction Q, P and Q. So P and Q what? P and Q we have the truth value if our both are the true. Otherwise that is false. So here true and true, that is our true, true and false, that is false, false and true, that is false, false and false, that is false, right? So now next we need to calculate the implication with this and this. So we need to use this in conditional statement with this. So we need to use conditional by both of these. So in our conditional statement, our value is false only if our the second statement is false. Otherwise, it is true. So true conditional statement true is true. True implication false. So second is false. So it means its value truth value is false. False implies false, that is true. True implies false, that is true. So like that, we can find out the truth value of this statement, and this complete is called the truth table. Clear? How to form the truth table of the compound proposition? Next come to the point converse, inverse and contrapositive. So what is the converse, inverse and contrapositive? Actually this is the cases of our the conditional statement. In earlier video we studied about the conditional statement, that is P implies Q. So these are the special cases of the conditional statements P implies Q. So what is the converse here? So our converse, if our statement is P implies Q, then converse is Q implies P. And what is the inverse? Inverse is negation of P implies negation of Q. And contrapositive, negation of Q implies negation of P. And these things are only the cases of the conditional statement, right? If we have the conditional statement P implies Q, then converse is Q implies P, inverse is negation of P implies negation of Q, and contrapositive of this is negation of Q implies negation of P. So let's take an example for this. Here, suppose we have the two statements. P is it rains, and Q is the weather will cool down. So in this case, what is our the P implies Q? What is the English statement of P implies Q? We can write that if it rains, then the weather will cool down. Right? Now, next, how can we write the converse? Converse is the Q implies P. So, how can we write the converse? Converse, it will be in the English statement. If the weather will cool down, then there has been rain, right? So, if Q, then P. Now, inverse. How can we write the inverse? Inverse is if it does not rain, then the weather will not cool down. Negation of P implies negation of Q just. Next, contrapositive. Contrapositive is negation of Q implies negation of P. So, negation of Q. What is the weather? If the weather will not cool down, then there has been no rain, right? So these are, we can write, if suppose we have given the one proposition and you need to write the converse or contrapositive, so you have to remember these notations. So our converse is Q implies P, inverse is negation of P implies negation of Q, and contrapositive is negation of Q implies negation of P. Clear? So here in out of these three which we read earlier, that is converse, inverse and the contrapositive, in which we have the same meaning as P implies Q. So what is that? Can you find that? What is that? That value is equal to this P implies Q? Yes, that is for the contrapositive. Means contrapositive what was? Negation Q implies negation P. So what we mean here to say this means same meaning is that the how can we say that the contrapositive is same as the P implies Q? Why? Because the values, the truth values of contrapositive, negation of Q implies negation of P, is same as the truth values of P implies Q, right? So for proving this, the equivalence P implies Q and it's a contrapositive, we can prove this by the using the truth table. Means by the truth table, we can prove this that this is equal to the this. Means both are the same meaning. Negation of Q implies negation of P and P implies Q. So here we need to make the truth table. So in truth table, we have the two propositions, that is P and Q, you know that. And the four rows here, true, 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 false, false, true, and false, false. So here we calculate P implies Q and the contrapositive negation Q implies negation of P, right, by the truth table. So first we need to calculate negation of P and negation of Q. So if P is this, so what will be the negation of P? Negation of P is true, false, false, then true, false, then true. And what is the negation of Q? Just opposite. If we have true, then it is false, false then true, true then false, false then true. Now P implies Q. What is the P implies Q? What is the conditional statement? Our P implies Q only the value truth value is false only if our second statement is false. So that is true false, that is false, and false true, otherwise all are the true. True true is true, false true is true, and false false is true, right? Now negation of q implies negation of p. So now negation of q implies negation of p. So if our second statement is false, then its value is false, otherwise all values are true. So here we have here the first is true and second is false, so that is false, otherwise all values are true, because false implies false, that is true, false implies true, that is true, true implies true, that is true, so all values are true. So now you can see here that this column and this column, truth values, true false true true, and true false true true, we can see that here in both these columns the truth values are identical, right? So according to this, we can say that our P implies Q is equivalent to the negation of Q implies negation of P, right? Similarly, if we have suppose Q implies P, so what will be the contrapositive of this? Here the P implies Q contrapositive is negation of Q implies negation of P, and both are equivalent, right? So if we have suppose Q implies P, so what will be the contrapositive of this? That is negation of P implies negation of Q according to this. And this is also the equivalent, means these at this q implies p and this negation of p implies negation of q have the same truth values. And you can see what is the q implies p. If we have the p implies q, what is the q implies p? It is the inverse, it is the converse q implies p, and negation of p implies negation of q, that is are the, remember, that is are the uh, inverse. So converse and inverse are the equivalent, and we can verify this by the truth table. So you can use, make the truth table both of these and check that these are equivalent or not. Clear? So next come to the biconditional. So what is the biconditional statement? So if we have the two propositions P and Q, then the biconditional statement P, and sign of biconditional is this P, biconditional Q is the proposition that is P if and only if Q. So the biconditional statement P is true that when P and Q have the same truth value, and is false otherwise, means the truth value of biconditional statement is true when both are the same, means both, if both are true then it is true, if both are false then it is true, otherwise that is false. And the biconditional statements are also called the by implications. So, and next, the implication, the biconditional P biconditional Q has the same truth value as P implies Q and Q implies P. It is true? Yes, because what is this meaning? This is P if and only if Q. Means if P is there, P implies Q is there, then Q implies P is also there. So P implies Q and Q implies P. So it means that P if and only if Q. So we can write this into this form also. Both are equivalent. And if and only if we can express is like I double F. This is means is also if and only if. So let's take an example for this. If we have the two propositions, P is you can take the flight and Q is you buy a ticket. So what will be the biconditional statement? P biconditional Q. What it in English statement? That is you can take the flight if and only if you buy a ticket. Clear? So now let's take the truth table of the biconditional statement. What will be the truth table of this? This truth table is we have the P and Q two propositions. So what is the biconditional? In biconditional we see that our truth value of the biconditional is true when both P and Q are true or both P and Q are false, otherwise false. So both true, so our value is true, both false, then it is true, otherwise if one is false, so this value is false. So this is the truth table of the biconditional statement. One note point is here that the truth table is the exact opposite of the exclusive or. You remember what was the truth table of the exclusive or? So you can see here what was the exclusive in our exclusive or truth table. Here, our truth value is true if one of these is true. If one of these is true, then it is true, otherwise it's the false. So you can see here, this is just opposite of this. If this is true, this is false. This is false, this is true. This is false, this is true. This is true, this is false. So we can say that the P implies P biconditional Q means the negation of P XOR Q, right? The negation of this. Clear? So next we here summarize our all Boolean operations by the truth table. So here our two statements are there, P and Q. So first what we studied about the in our earlier videos, negation. So what is the negation of P? Negation of P, you know that is false, true, false, then true, true, then false, true, then false. So this is the negation connective. And what was the second negative operator is here? Conjunction. So P conjunction Q. How can we calculate P conjunction Q? In our conjunction, what we have the truth value? If both are the true, then it is true, right? Otherwise its value is false, right? Now come to the disjunction, P or Q. So in P or Q our value is true. Our value is false if both are false, right? Otherwise it is true, right? Next, P XOR Q. So what is the P XOR Q? Here, if one of these is true, then it is true, otherwise it is false. So if both are false, then it is false. Both are true, then it is false. Next, P implies Q. So P implies Q. If our second statement is false, then it is false. Otherwise, all it is true, right? Now BP biconditional Q. So biconditional Q, we have the value is true if both are same, means false false, then it is true, true true, then it is true, otherwise its value is false. So here we study that this is the negation, this is our conjunction, this disjunction, this exclusive or, this is the implication, and this is the biconditional. So this is the summary of all connectives that we earlier studies, that is the truth table of this. So you have to remember these truth tables, and by these truth tables we can find our the compound statement truth tables. Clear? So now today's lecture is completed now. Thank you. Be happy, be healthy at your home.